tangent line, and you start with some x, then you go to some x naught, like, or x of 1, x of 2, and they're going to use that tangent line to get to the next point. And they're going to use that tangent line, using this for the slope, to get to the next point. Okay? Now, with these tiny little intervals going on, then you're going to have an even better approximation. So basically here, our m is going to be our dy dx evaluated at the point. And then our x minus x1 is going to be, like, let's say I went from 1 to 2 and I've done it 2 times, what would your delta x be? What's that change of x? Yeah, 1/2 or 0.5. So then we can stick in our previous y, find the slope evaluated at the point, and use 0.5 then for our change of x. Does that make sense? Alright. So in general, this is what we will do. A lot of times it looks something like this. It could go under or over, approximate. And actually, I already have that website up. So here, let's start. If that's the actual curve, let's see what Euler's would look like if we went from 0 to 1, and how many steps do you want to do first? Let's do 2, which means our delta x would be what? 0.5. Oops, I just looked there. So it would look like that. Let's say that we did 4, which means our delta x would be what? Point what? 0.25. Let's say that we did 10, which means our delta x would be 0.1. Let's say we did 100, what would our delta x be? 0. Alright, so you can see I just get better and better and better. Alright, this is kind of what we were talking about. So this is what you really want to know, like where you start with and how you get to the next y. So if you want to write this down somewhere, it's kind of what we were just doing on the board. So the x naught, y naught was the initial point that you knew. That's really how I started, and I think it is just the easiest way to keep it really organized and nice to find the next step. Okay? So we're just going to look at this one together, and then we'll actually do something. So let's say that this was my dy dx, and once we use Euler's method to approximate the y values. And could I actually differentiate this? Could I find the general solution? Yeah, and then I could plug in the point to get the particular solution. Okay. So, but this one wants me to use Euler's, and it told me that we're going to do a change of step of 0.1. Okay. And this one says 10 steps. We're not going to do all 10. That'd be crazy. Usually you just have to do 2 steps on the AP test. All right. So we know that we had our particular point that we started with was 1, 0. So what would be the slope at 1, 0? Well, the only place I can plug in is the x's. So 1 over 1 would give me a slope of 1. Okay, so I got a slope of 1, and I know my delta x is 0.1. So I can do the y minus y1 equals the slope evaluated at that point times our delta x. So I can add over what my y is going to be, which is just 0, plus my slope we found was, this guy was 1, and then the delta x was 0.1, so I can get a new y of 0.1. So that new y goes right here. How do I get my new x? Well, I take my previous x, which was 1, and I add on my delta x, which was 0.1, so now I am at 1.1. Is that okay? And you could keep going, and keep going. So here, this would be the y values if you did Euler's, and with those steps, like with the set value of 0.1, and here's what it would actually be when we went and solved the ln of the absolute value of x and found the c to be 0. Pretty close? Okay. How could we get it to be even more accurate? Smaller step size. Alright. We're not going to do that. Let's go to here. So this is how I like to set that. I just make a little table like this. If you want to label, you can, but I never do when I do it on my tests. Different things. So I make my table. I put my initial point that they give me right here. And then I'm just going to use y minus whatever that y value was equals our slope, plug in the point 0, 1, and what do you get out? 0. So our slope, which is right here, times our delta x. And our delta x was 0.1. Then you just go solve for y. So your new y is now 1, and this guy was from 0 plus 0.1, which is 0.1. Yes? Alright, so now I have this point, 0.11. So let's do the next step. Now we're using this one, not this one anymore. So y minus what, Josh? 1 equals, what's our slope at 0.1, comma 1? Because now we're at 0.1, comma 1. 0.1 squared times, what's our delta x? Our change of x right there, x minus x1, our delta x was 0.1. Go solve for y. Yes, all of this is without a calculator. You've got to do some little math. So what did you guys get for y? Okay. So our new point would be what? 0.2, comma 1.001. Is everybody okay with that? So the answer, to approximate, we had to approximate the value of 0.2, so we got to 0.2, so that would be our answer. That's the approximate value of 0.2. If we had solved dy dx and all of that stuff, we could get an even more accurate answer. All right. Do the next one. So if I started at 0 and I want to get to 0.3 and my steps are 0.1, I have to do it 3 times. want you to go to the previous page. And I want you to do this one. On your own. And you have x's and y's. So just, it's not written. So just use that space on the previous page. And if you still want help with it, and again, if you want to label, go for it. Otherwise, I would just make my lines. Negative 0.088.082. So got it. So math. So you guys got? nice writing.
Oh, come on.
Who was it? Depends on who it is.
Well, the microphone is on.
Dude, from my whole last conversation.
How we doing? Still working? Hey, that's pretty good. Sounds good.
I was like, yeah, I did.
Really good. Good. No, Josh, go. We're waiting.
Gosh, God, touch What?
We get to talk, you don't. Alright, so now these would all be kinds of multiple choice questions, okay? Now we're going to get to something, or it could be like a part B on a free response, it could be like that. Now we're going to see something that could be a whole free response that involves Euler, alright? So it looks a little bit different. Don't let it scare you. F prime just means what? What? dy dx. Alright? So don't let this scare you. Oh my. Okay. So use Euler's method starting at 0. And what do I know 0 what? 10. Okay, with a step size of 0.5 to approximate it up to 1. So how many times am I going to have to do this? 2. Go do that. When I do my slope here and plug it all in, I'm going to use this big bracket so I don't get confused. Even though I see a 0 being multiplied, f of 0 would be 10 times 0.5. All of that is just 0 though. Parentheses. Gosh, I keep doing that today. Parentheses. Alright. 0.510. Oh my gosh! Oh my gosh! I don't know what a f.5 is. It wasn't given to me. Oh my god, what do I do? Oh, what, Sarah? We just found it. Oh, she's so smart. You already got that, Matt Black?
Yeah, but if you had mentioned it, that's what I should have.
And some work. What do you get? Yeah, that's what I got.
Oh, yeah. Every time.
x equals. You need to do what? Do it a lot. Integrate how? Well, we said f prime is the same as dy dx. Oh, f of x is y. Now, does that look something that triggers in your brain what to do?
It's done.
So we're not implicit now. Implicit means we're deriving implicitly. Like here, we need to do what? Yeah, divide by 1 over y and multiply by dx. Separate your variables. Get your x's with your x, your y's with your y's. So you're solving a differential equation. You did a lot of this in AB. Don't just write what I write. Make sure you can do that. Quick little story. How many of you knew who Grace Kane was? Alright. Really, really, really bright girl. Went to Cornell. Super smart. Like, dude. Huh? Yeah. Okay. I think like 2 years ago. She's probably gonna kill me if she ever like listens to this on YouTube. Sorry, Grace, if you're listening. But super smart. She gets to the AP test and she forgot how to separate her variables. And so like this is like 6 points gone from the AP test. And it's like the easy part. She still got her 5 and did all of it, but she was so freaking out. She came back. Just really couldn't remember how to separate my variables. So don't just write what I write. Actually do it out. Cross multiply if you need to, and then do your division. Okay? Now you gotta integrate it. Have you integrated it yet? Did you get a negative out in front of that, Ellen?
Yeah.
Good.
All we use our point, right?
We will. Yes. Negative times a c is still just a c. Katie, you're so chatty today. Coming in late and then chatty, Kathy. We'll tell it when we're done. Okay. Is everybody okay with that part? Like when you e it, e to the negative x squared over 2 times e to the c basically, right? Because when you have a plus, you can still separate. And e to the c is just c. Are we okay with that? All right. So then what? I can subtract by 1 and multiply through by a negative. And negative times a c is still just c. Alright, so there is my general solution. We were given a point 0, 10, so I can go solve for c. Have you done that yet? Okay. I didn't expect you to. Just kidding. So there is your specific solution. So now let's look at the second part of this, part B. So find the solution in terms of x when x is now 1. So now we got to plug in our 1 and solve for I. Good. Hugh, what are you thinking? Do I want to know? Okay. Okay. All right. Oh, sorry. I don't know why I just said that. Okay, so y equals 1 plus 9 e to the negative 1 just write it again. Alright, so we found our solution, our particular solution to what? Y equals 1 plus 9e to the negative x over 2. Okay, so now it wants me to evaluate this integral. Well, I know that that was f prime, right? And this is basically f of x. That makes life easier, because the antiderivative of f prime is f of x. But the other thing I have going on here is a infinity sign, so I need to put a what, McKady? On the limit. If you leave out the limits, you're going to lose a point. What do you want to call that up there? B? So see if you can finish it. Check your answer with me. And it's easier when you have negatives of the exponent to move them over the division bar. Makes it easier to take the limits. You got it? Let me double check what it is. Real quick. Yeah. Well, the antiderivative of f is f. So that's what I put in there without the integral. So you already did the antiderivative, so the integral goes. But you still have evaluated from those two values. Alright, Matt, take me through it. When I plug in b, I get what? 1.
Plus 9.
As this goes to infinity, this would go to 0.
Minus 1 plus 9.
Yeah. That could have been an AP question. Worth 9 points. Everyone is worth 9. And when you're done with that and ready, we can take our quiz. Oh. Almost forgot.